All right, we are finishing up this part of chapter 2, so we're going to do 2.5. It's more sketching, so it's very similar to what we were doing a couple days ago. It's just going to be more graphs or 2 functions on a graph instead of 1. Well, let's go ahead and start with the warm-up where we're asked to sketch 3 cosine of half of x. Review on how to label your x-axis. You need 8 tick marks. Okay, 8 tick marks. Remember, we are counting from 1 to 8, putting them over pi. So 1 pi over 8. Oh, 4. I'm sorry. 1 pi over 4, but we're counting from 1 to 8. 2 pi over 4. So 2/4 is 1/2. 3 pi over 4. 4 pi over 4 is 1 pi. 5 pi over 4. Remember, every other one reduces. 6 over 4 is 3 over 2, so 3 pi over 2. 7 pi over 4. And 8 pi over 4, which is 2 pi. Okay, that's your x-axis. Your y-axis depends on your amplitude. So if we look at this equation, it's 3 cosine, which means my amplitude is 3, so my y-axis has to go from all the way up to 3 and down to -3. And then we're going to sketch it from here. Okay, let's sketch normal cosine so we remember what it looks like. Normal cosine starts at its amplitude of 1, ends up at its amplitude of 1, bottoms out in the middle, and crosses in between each of those. Okay, that's normal cosine. You do not have to have that on all of them, but it's just kind of helpful sometimes to see what we're dealing with. Normal cosine looks like a bowl, starts up at its amplitude. So let's talk about how this one's going to be different. We already talked about the amplitude, so your amplitude is going to be 3. Your frequency is changing to 1/2. Which means only half of your graph is going to happen over this 2 pi. You look at normal cosine, it's this bowl. If you chop that in half, it ends down here. So it starts up at its amplitude and it ends down at the bottom. It's going to look like a goofy little sledding hill. Okay? So basically, again, all of these points, so this is half of it. So it has to be stretched out. So this bottom point has to be stretched over here to end here, which means this middle point's going to get shifted over here. Okay, all of those. And the other half isn't even happening because we don't even have to do that. The other thing is that your amplitude is changing. So instead of starting up at 1, we're starting up at 3. We're going to cross in the middle. And we're going to end down at the bottom. And then that's going to be it. Just this hill down to the bottom, and then you're done. Again, the pink and the yellow and all that jazz doesn't have to be there, but it is helpful sometimes to have that. So you don't have to be deleting it like I am. I'm just going to show you what it looks like without all that stuff. Okay, the actual graph we were asked to draw. Looks like this. That's half of cosine. That's it. And it's 3 up at the top and down at the bottom, so it's 3 cosine half. All right, we're still graphing. We're just going to graph 2 functions on one axis, and then we're going to be able to see how many times they intersect. That's the goal, okay? So, solve systems of equations by graphing. We did this in Algebra 1. You did it in Algebra 2. You're figuring out how many times things intersect. That's what we're doing, okay, with trig functions now instead. So regular sine and regular cosine is the first thing we're being asked to graph, which is fine. So let's just do regular sine first. Neither of these two graphs have a change in amplitude. They don't have numbers in front, so we'll just label our y-axis 1 and -1. We'll start with sine. Sine starts at 0, so start at 0. Okay, regular sine crosses at pi, ends on the axis at 2 pi. It starts at 0 and goes up, so it tops out at pi over 2, bottoms out at 3 pi over 2. That's regular sine. And that's all we were asked to graph. We weren't even asked to change it, so we can stop. Cosine. Regular cosine. Starts at the amplitude. So it starts up at 1. It ends up at 1 at the amplitude. It bottoms out in the middle, which means it crosses the axis at pi over 2 and 3 pi over 2. It just makes a bowl down and back up. All we're asked to do is find the intersections. This is exactly what your spaghetti lab looked like, okay? This is what you did. Intersects here at pi over 4 and here at 5 pi over 4, because that's 45 and 315 when they are both radical 2 over 2 and then both negative radical 2 over 2. So this has two intersections. And that's all we're answering. Graphing them to find how many intersections there are. Okay? This one was simple because we know exactly what these look like. Sometimes it gets harder as we change them, but we're going to do our best. Okay, these, neither of them have amplitude changes, so my graph's just 1 and -1 again. Okay, don't forget to do that part. Let's do the first one. Cosine. The only change is that it's 2 instead of 1. So normal cosine, think through it. Normal cosine looks like this, like a bowl. 2 of those is going to look like this, okay? Sometimes it's easier if we do the second rotation in a different color so you can see the 2 rotations of it. So I'm going to do that for this one. Regular cosine starts up at its amplitude. Since it's going to happen twice, it's going to have to be completely done with its first rotation by pi, which means it's going to be in the middle, down at the bottom at pi over 2, and cross in these 2 places. The second rotation is just going to mimic that, so it'll start up at the top, it'll end up at the top, bottom out in the middle, and then cross in the other 2 places, okay? Those are 2 full rotations of cosine without an amplitude shift. So here's my first rotation, comes down, ends up at the top, and then the second rotation begins, so it starts again at the top, comes down, bottoms out, ends up again at the top. That's 2 rotations of cosine. Okay, 1 of each color. All right, let's do sine in teal. Sine. The only change here is the frequency, but this frequency is getting slower. Okay, so if you think about normal sine starts at 0, comes up, down. That's 1 rotation. We want half of that, so we just want this first hill on this whole thing. So starts at 0. If you look at the half of it, it's going to end at the same place it starts, so it's going to end on the axis at 2 pi. The only other significant part is the top of it is directly in the middle. And then that's going to be it. It's just going to come up and go down and stop. And then we're in charge of counting how many intersections. So it appears to intersect 1, 2, 3 times. So 3 intersections. And that's all we were asked to find. Okay? So it's just the sketching 2 on 1 graph. I'm not saying it's easy, but you guys can definitely do it. All right, one more. If you look here, the amplitude has changed on the first sign. It's only a half. So I'm just gonna make my y-axis be half to 1 and negative 1/2 to -1 so that we can see exactly where that sign stops. The cosine frequency is not changing, so our amplitude isn't changing, so we're okay. So sine, half of sine in the beginning just changes the amplitude. It doesn't change the frequency, and there is not a number inside with the x that would change my frequency. So it's gonna look like a normal sine curve. It's gonna start at 0, come up and stop. It's just not gonna go up as high as it normally does. Sine starts at 0, it crosses at pi, ends at 2 pi, tops out at pi over 2, and bottom at 3 pi over 2. All of that curve is staying the same, it's just not going up as high as it normally does. Just the amplitude was shrunk down to a half. Okay, so that's 1/2 sine. Now cosine has a half as well. However, the cosine 1/2 is the frequency, not the amplitude. Okay, your amplitude is still 1 here. The frequency is what's changing. So only half of cosine is going to happen. We just did half of cosine, I thought. Oh yeah, up here. So half of cosine is just the sledding hill, okay? That's what this is gonna look like. Nothing else about it is changing. So if you think normal cosine is a bowl, half of cosine is just gonna be the sledding hill. So you're gonna start up at the top. Your amplitude is still 1, so cosine starts at its amplitude of 1. It's going to cross the axis in the middle, and it's going to end at the bottom at -1, because all it's doing is this little hill. So it just comes up, bloop, just like you're going on down. Okay? That's it. It's taller than the sine, because the sine's only half, and the cosine's all the way up at 1, but only half of it happens. And they only intersect, oh, that's probably a lie. No, that's right. They're going to only intersect here. There's just one intersection. It's just kind of hard to see when you're coming at it from such a different angle. Let's see if I can make this clearer. This is coming up, down, and then through. Okay? Got stretched out. So it only has one intersection. Okay. That's it. Hopefully you're getting more confident with your sketching. Keep practicing. Go ahead and do your 2-5 worksheet.